Welcome to Math, Minecraft Computers, episode I31, where we are going to build the D-type flip-flop in Minecraft. Alright, as you recall, the D-type flip-flop was a set of SR latches that are arranged starting with two OR gates, an able and a data input, going to a couple of OR gates to a NAND SR flip-flop, adding to some AND gates, and then going to two NOR gates where we actually have an output for Q and Q prime. We are using this to actually store our data. We're going to start by building our OR gates here. That's going to be 3 in this direction, and then we're going to skip 3 and do 3 more like this. These are our initial OR gates that you see that we put, and we're going to build these in this direction. So I flipped it, and you can see down here that I've modified that. Now, if you remember, since these are OR gates, we need to have wire all the way across the top, like so. And there's an outer input here and an outer input here. Now these outer inputs, as you recall, is the data line, but we have to do an inverter first. So here's our inverter and a piece of wire, and then we're going to go down 1 and bring it up over here, like so. Now we're going to go across the top of that, and this will be our data switch will be right here. I'll bring it out 1 more. That'll be our data switch, and of course we need an enable switch in the center here. So of course our enable is going to wire across here. And we just need to bring it up. Put that back in place. And we won't worry about that. We need to bring this up like this. And here we go. This then is our enable switch here. Now, with this switch off, right here, you can see we've got our inverted wire goes over here. Now what we don't want is we don't want our enable on. See, now it looks like the enable on. Our enable is not on, it's just this inverter. So what we need to do here is we're going to put 2 sets of repeaters like this. That will make sure that when we have the enable line on, which is here, you can see it only goes in the direction we want. So this enable line goes in this direction. Get my repeater, there we go. Get it correct. In that direction. Now that verifies that when our enable is off, we've got our repeater set properly. And then from here, we're going to go down 1 and then down 2. And our wire will run under here at some point later to our other gates. But let's build out what we have here. Now coming off this, we have, as you'll see down here, 2 NAND gates. They line up like this. I'm keeping this as short as I can. Of course, the NAND gate then would have switches on top of it. 2 torches on top of it like this, a piece of wire, and we would come directly out of there. That's a lot of the difference in this case. And that connects in directly there from our OR gate. Now remember, an AND gate would have a torch here. We don't have that because this is an AND gate, so we're set here. And then this one is going to come out of the center of this one and line up like this. So you'll notice the difference here is this is coming out of the center of the OR gate. That one is coming out of the right side of the OR gate. And we do the same thing. This is an input, and the torches, like so. As you can see in the diagram, these 2 flip-flop. And so the way we're going to do that is bring this out and over like this, and in this direction. And we're going to put a repeater coming right out there. So I'm going to replace that with a repeater to make sure it's one way. and then we come over this way, and it plugs into here, like this. So there's our input coming out of there, and it crosses that way. And then we do the same thing, except now we're going to elevate this. So with our wire, our enable wire running underneath these, like this. And then we need to reset this wire here. So there's our connection from, get this out of the way. All right, then our connection from here actually needs to come up and over into there. So we're just going to bring this up 1, like this, and then 2, like this. And that will let us bring this up, and then we're going to have 3 pieces of that come this way, like so. And then we bring it down here. And into this. So here's our other connection over. Once again, we want to make sure that we have this set to 1 way. So we put our repeater there, and we bring this over. And now you can see that we have our cross connection to this particular one, and underneath here, we have our connection there. Now the other step of those is, you see we have to come out of those still, and they're going to go into AND gates. Now our AND gates are going to be a little bit different when we continue to build this to here. I'm going to leave those open so that can be seen. But in this case, our AND gates are going to line up with these outputs. Right here. So our first AND gate is here, and our output from this, so you need to move this gate 1 forward to here, like this, and that is a AND gate properly, so we need 3 different torches on that, put our wire on top of this, and then that is going to plug into this input here. And then here is going to be our enable wire. That's the input to this other, like this. So this is the enable coming underneath, and it connects into here. And then it's going to do the same thing on the other side, except that we're going to keep running it underneath in that direction. Now the difference is this gate, this AND gate here, we want to bring it out on the far right side. So I'm going to start right here. And build it like this. You're going to build it like you would do a multi-input gate, like so. And the torches go back here. Oop, got that in the wrong place, of course. That's pretty easy to see at this point. This line's up here. So this is going to be our AND gate. Put our torches here. We put a wire all the way across. And then this time we're going to bring our AND gate out here. And that's why we wanted to do the output over here. That's why I had to do this multiple, otherwise the output has to be in the center like that one. Okay, so now that we have that done, we know that this is going to be our enable input here. So that's going to go down. Right here. And connect into this side at this point. is an up. And we've got that connected in. So that's our enable. The enable is coming on the inside of these two gates. And then that means the connections from these gates come to the outside, which you can see is going to be right here. Like this. So this gate connects into the outside of this gate, and the enable line comes into this one. And you can see that that one is there, and the enable line comes there. We just need a piece of wire here. So far, so good. We've got this set up. And then I can get rid of these and fill those back in. Okay, there we go. So those are two AND gates. Those two AND gates are going to go directly into OR gates after one piece. So these OR gates are 3 long. 1, 2, 3. We have one over here, same way. 1, 2, 3. These are NOR gates, though. So we're going to bring the output out of this one here, and exactly on the opposite side here, because these two are going to crisscross, as you recall. This one needs to input into here, and this one needs to input into here. All right, so the easy way to do that is we bring this out, over, into here, like this. And then we have to cross this side is going to be the input over onto that side. So that's pretty easy to accomplish. We're just going to have to bring it up somewhere and over this wire. And here's as likely a source that's going to come over here, and we can bring it over this wire. Too high, and then bring it down here. So you'll see if we connect that in this direction, we're good. So here you go, this connection comes up and over to here, and then into this gate. This is the NOR gate, it's got the negated output there. This is the same, this is its output, comes up and over, and connects into that gate, and then of course we come off of this one, and we come off of this one, and I can do it here too if I like, but I'm going to go ahead and bring it forward off of there. And then this is going to be our 2 blocks that will light up. It will store our bit. So one of these is Q, and one of these is Q prime. Now notice on our other map that we connected these gates in the opposite. We have the enable gate connecting on the outside of the AND gates, and now we have our outputs connecting. And then that also means that we now have our Q and Q prime outputs, and we can go put our inputs on and begin to test this. Now, the other thing that we might need to do is a few repeaters in here. For instance, this wire down here is probably not going to make it, but we can check that really quick by just flipping the enable on. As you can see, it actually makes it all the way, except right here. So let's just bring a repeater down here where we can see it. And now we've got enough of the signal that we're good there. And then we can flip our data line too. Everything's a pretty short run here, so it shouldn't take a lot of repeaters to carry the signal because it's fairly short. Now, the question is what happens when we do an enable. And you can see that it flips over here. I can do this. So there's our characteristics. It shows you that this is going to be Q, and that this is going to be Q prime. So that means when this is not enabled on our data, we'll go ahead and just label these real quick. This is data, and this is enable. When our data is off and we enable, it should move to Q prime, which it did right there. When our data is on and we enable, it should move to Q, which you see it did right there. And then of course our other characteristic is when it's not enabled, I should be able to flip this all I want, and nothing changes. You can see that is the case. And then of course when I enable it, it moves over there. I should now be able to flip this without any change in the circuit until I turn off the enable. So there you have it. Turn this on to move it over here. Q comes on. I can't modify the data all I would like to at this point until I turn this off. And only when I enable it again will it come on. So that is our D-type flip-flop. The only other thing that we want to do is, like we've done in the past, is we want to denote this. It actually starts right here. This is its inputs. So what I'm going to do is I'm going to grab a blue terracotta block, and I'm going to replace my white. And then what we're going to do is denote the edges of this circuit with a border. Alright, this just shows now if we wanted to copy this, we would start at that block down there, and we would copy to this block right here, which would catch that tallest repeater sitting on top of that and all of this wire. And so that is it. That is our D-type flip-flop. That's the last thing we do is to get our sign back here. And let's label this D flip flop. Alright, that is it. Keep in mind that Q is the bit that we would store. It is stored right there in that, or this line right here. There we have it. A working D-type flip flop. We have the blue area which would be copied in if we wanted to move this somewhere. That is it for I31. Keep on learning. Give me some likes if you enjoy this. Subscribe if you want to see more. And that is it. I'm Roy. Out.